Hello, this short video is about getting started with Ansys Fluent 2022 R1 on Ansys Gateway powered by AWS. In this short presentation, I'll be talking about customer journey, CFD processes and operating systems, how to create resources, file management, as well as giving a quick demo about how to run your simulation on the gateway. Very quickly about customer journey. You have different roles. You may have a team lead. You might have in your team simulation engineers, interns. Any of these folks might have heard about AWS. That Ansys is available on Gateway. They want to get access to it. They can create a IT request at your company, and the IT person who also looks after the AWS will subscribe Ansys Gateway on AWS Marketplace. He has to self-onboard, and after onboarding, he creates the project spaces. All these details are given on the link here. There's a separate video for this. And then once IT creates the project spaces, he or she gives back the access to the team lead who can set the budget, create the resources. He or she can also delegate creating resources to a simulation engineer or power user. In case of scenario that you have an intern, maybe you want to create resources and ask them to only use the resources. So that way you have a control on it. All of these details are provided on the Ansys forum. The links are given on this presentation. First link is about the marketplace subscription, about documentation, goes really deep into types of user roles, how to get started, how to self-onboard is on the forum, and the gateway is available at gateway.ansys.com. Alright, so moving on, looking at the CFD processes. So as you know, in CFD, you have pre-processing, solve, and post-processing steps. Now, for pre-processing, one can use Spaceclaim or Discovery Modeler. For meshing as well as case setup, you are using Fluent. In case of Spaceclaim or Discovery Modeler, only on Windows. But for Fluent meshing, Fluent case setup, Fluent solve can be done on Linux as well. Solve can be on a single node, which could be Windows or Linux, or multiple nodes using a cluster, which can run only on the Linux operating system. Post-processing, when it comes to post-processing, can be done either on Windows or Linux. Okay. Now let's connect these dots. So I'm going to walk you from left to right. Suppose you want to start with the geometry. In this case, as I said in the previous slide, you can be Discovery Modeler or Spaceclaim. In case of Discovery Modeler, it can only run on a graphic instance which has a NVIDIA support. Spaceclaim can run on either graphics instance or a basic computer instance. Even in that case, if your model is big, it's graphics intensive, we recommend that you use a graphics instance, which could be, on case of AWS side, could be G3 or G4DM. Other recommended instances are C5, C6i, M5, M6i. Okay, all of this information is in documentation under recommended uses. So please make note of these instances and try to adhere to these. Now, we do support Linux VM. You can do, as I said, you can do only Fluent meshing and Fluent solve, or as well as post-processing. Now, if you only need one node, single node, you can use either Windows instance or Linux instance as a virtual machine and run the job locally. If you want to do it, say your model is big, you want to go to the cluster, you need to have a Slurm cluster which requires multiple VMs. First you create the storage, then you create the Slurm controller, and then create the Slurm cluster, and you run the jobs there. Post-processing, as I said, can be done on the graphics instance, it can be done on the Linux instance. All of this information again is provided in the documentation or in the forum. On the right side, for the clusters especially, we want to use C5N 18x large or 32x large C6Is or SPC6A 40x large. The reason for that is that we need EFA, which is Elastic Fabric Adapter, which helps us to communicate with different nodes. Now, coming to the file management, that's one of the issues that maybe you started doing your work locally and you want to move it to the cloud. When you connect Gateway, again I'll show it to you, your local drives are automatically mapped into the graphics or VDI. You can just drag and drop. If the files are small, drag and drop. If files are big, maybe you want to use WinSCP, secure file transfer, OneDrive, or whatever your company supports. And again, this slide shows you that a lot of things are mapped, or you use the file transfer agent. Okay. Moving on. Now let's look at the Ansys Fluent running on Gateway. Okay. First of all, how do you log in? Login is very simple. You go to gateway.ansys.com, use the credentials provided by your IT. So once you log in to gateway.ansys.com, you will see this particular page. Welcome to Ansys Gateway powered by AWS. There are some quick links here, how to get started with Gateway. Again, these links will take you to documentation. If I click on it, just very quickly, I'll show you. Right here, you have getting started with Ansys Gateway. Here, if you just navigate these pages, where do I start? Something simple, right? Type of user roles, I talked about in the previous slide, how to get you started. Let's look at this one very quickly. And here it talks about different role, tenant administrator, project space administrator, and simulation user. You can click on these links to get to the right page. And there are also some how-to videos that are available on YouTube. Okay. Other thing before I move on, let's go back to the Gateway page. And for the help, you can go through the help on the question mark here. You can get to the help, or you can get to the support forum. This is the place you will find questions, answers to many questions that you may have. If you don't find it, please feel free to submit a new question. This is being monitored by the ACE team. For the forum, you can search anything you want. You can start a new page, and just very quickly I'll show you here the link for onboarding by the IT person, just to give you an idea here. All the instructions are given here. Now, once you land here, if you don't see anything on this page, that means you do not have access to any project spaces. You have to go back to your IT administrator, ask them to create the project workspace. If you look at this page here, as you can see, there are multiple tabs, multiple tiles here. These could be different departments, different projects, whatever is required. Each of these tiles can have their own budgets. That way it helps you to monitor the cost. So this is the one I have created for CFD. If you click on this, you will see that I have created multiple resources. In this video, I'm going to show you how to create these resources, but in the interest of time, I will go back to start using these. So let's create very first one, how creating a VM for running Fluent on either Fluent or Spaceclaim or Discovery Modeler, whatever is required on a particular VM. I can go ahead and say new resource here. I can have created a new resource, virtual resource, HPC cluster, as well as file storage server. So let's go to virtual desktop. You can give a virtual desktop name, give the name that you can identify. You may have different AZs or equal availability zones. You can pick and choose that. Right here, you can see I have multiple zones. So let's go. If I use 1F, again, if you don't know what these are, please talk to your IT person or review AWS site. Next, here are the templates. I'm going to skip this piece. Once you create a VM, you can create a template for future use. Next, you can have Windows or Linux operating system. Next, add applications, right? So this is where we have a list of different applications that you can use, you can install in your VM. Since I want to do the fluids, I can type fluids here, fluids 2022 R1. Now in this case, as you can see, the license server information, or if you have elastic licensing, you can connect that. I can also add, say I need to use 7-zip, but I want to zip the files. Similarly, I can add multiple applications here. I'm going to quickly do it, like Notepad, and say Firefox, and maybe I also need a WinSCP to transfer the files later on. Next, this is where you select the hardware. The link at the top gives you recommended hardware. If I click on it, I'm going to click right of fluids. As you can see, it says C5, C6, M5, M6i, G3, and G4DN. G3, G4DN are graphics instances. They provide you much improved pre and post processing. For Spaceclaim is important. For large models, for discovery, you really need to have G3 and G4. Similarly, the question will come up later. Let me show you here about the clusters. Same thing, C5N, C6i, HV6A, because we need EFA, which is highly recommended for CFD solvers. So let's go ahead. In this case, I'm going to go C6i. And I'm going to take 8x large, has 60 cores, has a decent size memory, and its cost is nominal. The cost you see here is a list price. May not be reflective of what you end up paying based on your agreement. Hyper-threading is turned off by default. We want it that way. The disk, you can have a disk of whatever you require. That's fine. You can pick and choose. We really don't need additional disk size, but if you really need, you can add that. Next. And here are the tags. These tags are useful to provide some kind of tracking for the budgets later on. So I need to give this information, who is creating it, and what is the purpose. Next. Once this is, all the information is given, you can review it. One thing you may have noticed, right at the top, we have some kind of wizard. I can go back and review the different things. Just to be sure. Once everything is done, I can click create desktop. This process, this creation will take about 15 to 20 minutes because it's going to find the machine, it's going to provision it, it has to install fluids and all these applications. Once you create it, it's good to go. You can also save this as a template. So next time when you come, you can use this template to give you all these pre-selected items. So in this case, I'm going to cancel it because I already have a VM created. So I'm going to cancel this here, but you get the idea. So this is the VM which would have been created in the previous steps. Okay, so this is the Ansys CFD C6i. If you look at here, status, I have looked at applications. In this case, I have 7zip, Fluids, Firefox, Notepad, WinSCP, and I also installed software called Skate. All I need to do at this point, connect. This is going to download a RDP file locally here. And I'm going to open that. As you can see, it is opening now. This is any Windows VM. You can do anything you do on your local laptop at this point. Whatever is installed, you can access it. So as you can see, I have a Ansys 2022 R1. I can install, I have already installed Fluent and Spaceclaim. If I click on the Spaceclaim here, and I have a Spaceclaim. Now I need to have some files. Let's go back to my file manager to show you that if you go back, in this case, I have also linked OneDrive. And I can go to this PC here and go to my local machine, which is a D drive on my machine. So I need to go to Cloud Demo. And I can just drag and drop the files right here, either on the desktop or any folder, or I can even go directly onto the Spaceclaim. And here's my T-junction. At this point, the operations are very similar to what you do locally on a laptop. Nothing more. Okay. So this is what I showed you. This is how to create a virtual machine on AWS. Now, the similar process is for the Linux. All you need to do is start with the Linux OS. In case you missed any step, let me very quickly show you. You can go to documentation, go to Gateway, and go to recommended uses, and go to then go to applications, go to Fluent here, and the steps are given here. Part 2, creating a cluster. As I talked about, in case of creating cluster, it requires 3 steps. You have to create a storage, you have to create a controller, which basically helps you to run the jobs on the cluster. So as you can see here are 3 tiles, 3 different VMs. I'll show you step-by-step process. So let's go ahead and create a NFS drive, NFS storage. I can give a name, I can say CFD. Make sure you're creating the same region as you have created the other VMs, just to it helps you to avoid any kind of lag. This is going to be Linux NFS storage. In case of Fluent, we recommend to use ultra high. It's very small VM, T2X large. Storage could be anything. This could be storage, could be an individual user, or this could be for the group. So let's go ahead and say 128 is good enough for now. For demo, next. Once I hit create file storage, it will create that. Very simple. Which again is very similar to what I did with Windows Desktop. I'm going to cancel this and we'll move on to the creating controller. So as you can see here, just for the completeness, here the NFS storage, it is running state. If you look at right here, in case applications, I did install KDE, you don't really need it. Once this is running, you need to come to state storage and create a storage, a shared storage. In this case, I already created one, but I can create one more here if need to. All I need to do is create a storage, give a name. Once this is done, this will show up and it will get mounted automatically to the controller. And your Fluent software eventually will be installed in this particular shared storage. So in this particular case, I already have a storage called AKNFS October 25th drive Y, which I'll be using later. So this is important to note. Second thing, we'll know later on the name of the machine, which is host name. Okay. Now let's go ahead and create the controller, which is again very similar to the steps I just showed you. I'll go ahead and create a virtual desktop controller. Give a descriptive name. Next, I'm going to skip the template. It is going to be Linux. The controller has to be Linux. Next, add application. Here I need to add application called Ansys Fluent 2022 R1. I need to give license information and the shared file location. This is the file location I just talked about. And I'm going to put that name here. That is very critical. Add application. This is a controller. I need to have a Slum controller installed. And this is the one. Slum controller. Give a password. It's very basic password. In this case, I just put Slum1. Add application. This is a Linux machine, so you need to have some kind of a Windows desktop environment. KDE works fine. Machine type could be again C6i. X large is fine. In this case, if you want a bigger machine, let's suppose you want to run something locally to test it out, you can use a bigger machine here. Hypothetical disabled. Next, file size. I already have an NFS drive. I really don't need any extra space. Next, and I get the tags. So as you can see here, just for confirmation, I have Ansys Fluids, KDE environment, and Slum controller, 16 cores, C6i, and create workshop. virtual desktop. If I click this, it's created. It will take another 15-20 minutes to create that. Now in this case, it's going to install Fluent on the Linux machine. I can save this as a template in case there's a need for it. If not, I can escape. I'm going to cancel this step because I already have one already created. So I'm going to show you that one. And this is my controller. In this case, applications wise, I had Fluids, I have KDE and some controller. One caveat here is, since I already had done the Fluent install earlier, I only need to install the host just to connect it. You can look at the documentation. And a KDE gives you the option of remote desktop. And I can connect to this. You will see the interface looks different. We are using KDE. So once you see this screen here, I can right click. I can open a console. This is Linux operating system, so you need to little basic Linux. So I can go to CD, MNT, AK, that is my drive. In this drive, I already have some files. I have Ansys Inc. where this is where my Fluent is installed. All of these files, what you see here, have been moved from my Windows VM. I'll show you in a second. So how do we do that? Even here, I have access to a file manager, which you are used to in Windows. Right here, file manager. They mounted here, and you can see they have multiple files here. Now, how the files got here? I moved them from my Windows machine. So let me quickly show you how that was done. So if we go back here on the Windows machine, in this case, if I go to Explorer here, I can mount my drive. You can go to this PC and say mount my drive. Go to computer, say add a network drive, and I need to know, in this case, what is my IP address. How do I know the IP address? I can find that through my gateway. Go to status, settings, and this is my IP address. I take the private IP address by following the process by typing the number, like if you look at the example here, is basically copy that, next, and just browse. This is the one. I want to expand that. This is my NFS drive. And OK. Now at this point, once I do that, that is mounted here. At this point, I can open that. I can drag the files from my Windows to the Linux machine, and they are available on the Linux machine. Very simple process. Okay, going back to my Linux machine. Once I have the files, I know where my Fluent is installed. It's a very simple process. I can go ahead and run it by saying pwd, means where am I right now. I want to go, once I know where I am, where the files are, I have my working directory, that's where my files are. In this case, I have aircraft, files, pwd, and all I need to do is find my Ansys location, v221, Fluent, bin, Fluent. At this point, I can give number of cores I have. I have 16 cores here. Make sure you don't put more than what you have. Put 16 cores, working directory, start. Depending on you want a meshing or solution. And you can do anything you want at this point. Now, this is, you can run locally. If you want to run this on the cluster, we have to also create a cluster. So let's go very quickly to creating clusters. My gateway window, new resources, And for the creating clusters, I have to know which is my controller information, so I can connect, I can tell that the cluster is using this particular controller. For that, I need to know two things. I need to know what is my IP address, and I need to know what is my host name. Okay, I'm going to go ahead and write down these numbers. Go back to creating cluster. I can give the cluster name. It helps you to remember things. Next is one particular application called Slurm node with EFA. Management host is what I talked about. The Slurm host name is private IP and Slurm password. When I go to, so if I go back here, go to UAT, look at my controller settings, I need to put this IP address, sorry, I need the name, host name, I need the IP address, which is private IP. This helps to have two windows open. Go to NFS prep. Here I have to give the name, follow the syntax. It says host name. In this case, settings, host name is this particular one. And give the full name as shown here, share, and you need to give the file path. The storage, what we called it, was this name. That's where the files are. Mount, save information, and yes, EFA driver, nothing. Next. Pick up the machine. I want to see 5N, 18x large. That's the largest one I have. I need that. Next. How many nodes I want? I can put 1 node, 2 node, I can go to 20 nodes. So let's go for 4 nodes. Next, same information, created Y, that's about it. And create the cluster. Once this cluster is, we hit click here, it has to go and find these nodes and provision them for us. Once they are provisioned, I will see on my panel here, as you can see, HPC cluster status, node details. You can see here I have 4 nodes. They are running in running state. It's critical to make sure they are all running before you do anything with those. They each one have IP addresses, which will be useful in the background. Now, technically speaking, I can increase number of nodes, I can reduce it. Once you do that, it has to go back and reprovision those. But that is possibility to upsize or downsize. I'm not going to do that right now here. And as you can see, they are running state, everything ready to go. Once that happens, I can go back to my Linux cluster. I'm going to stop this. I don't want to run this thing. I look at command called sinfo. sinfo says I have 4 nodes, they're idle. Now what it's telling me that they're idle means I can go ahead and use them. At this point, there are multiple ways I can run the jobs. Before I do that, let me show you a quick slide here to walk you through the steps. So this particular slide walks through all the things you can do. If you have a small simulation, as I showed you, you can type mount, NFS directory, whatever that was, Ansys Inc. and launch Fluent window and run the job locally. If you have large simulations, you can use interactively, you would give the same command, what given here, but then click on the scheduler, click on use Slurm, in the partition put ACS_cluster and node current machine. In the solver processes, give how many nodes you have, how many scores you have available, and use that. Again, please be specific, be clear, making sure you don't oversubscribe, and click start. If you want to run things in batch, that can also be done. You can do through command line on a single node or on the multiple nodes using a Slurm script. Let me show you these different scenarios in action. Okay, so let's go back here. So first of all, making sure that I have the files here. This is aircraft file. I can go ahead and say, first option, I want to run locally on this machine. I can say Ansys Inc. If I want to let it launch, let the launcher come up. If I want locally on this machine, I can just give number of cores I have available and start the mod process. If I want to run it on the Slurm cluster, I go to scheduler. I say use Slurm. Node, current machine, and I have 4 nodes. With how many cores I have? This was CL, I use C5N. So let's go ahead and give number of cores. Again, I can undersubscribe, but please don't oversubscribe. If I want to double precision, I can click on it. It's a solution and start. Keep in mind, I'm running on 144 cores at this time. You can see here, if you're Fluent, how it works, and you can see I have 144 cores available, and 143 they had different host names. And then at this point, I can read in my case file. And run the job on this machine. So I'm using a controller to send the job to the cluster at this point. Once it is read in, again it's pretty fast here. Go to graphics screen and let's look at it. Display. As you can see, there's a plane here. If I want to run this job, all I need to do is, as you know, go to solutions and give number of iterations. Just for the display purposes, demo purposes, I'm just going to say 5. I think initialize, that's fine, I can do that. You can save, once this is done, you can save the files, you can post process it locally, or if you want to, you can take it back into Windows machine and post process it there. And it's done pretty quick. It did 5 iterations. And let me just show you in the console. Because I'm writing out only third ones. So let me just show you, just so that you know. I'm going to add the 5 more. The next number is 6. So this is how you're going to run this in the controller. I'm going to get out of this for now, just to show you something very quick here. Now, if I want to run this in batch, I don't want to monitor, I don't want to babysit it. If I go back to my PowerPoint, I can also run this using a Slurm script. This script is very standard, it requires very simple changes. So let me show you that script. Let me show you that script right here. And I can do either, I can do VI if you're okay, EFA Slurm. And it's a very simple script. So you have to give the name, how many total tasks, how many nodes per node, how many cores per node, and make sure that you give the name of your NFS drive correctly. And what is your general file. Once you have this file set up, you can quickly make a note of it. Again, this file is provided. It could, if it's not available directly here, you can find it on the forum. You also need, in addition to this, you need to have a simple journal file. If I show you run journal, this one is a little bit much more elaborate, but all you need, mainly you need a read case file and solve it. In this particular case file, journal file, I also have other commands to track the performance. Once everything is done, all I need to do is say sbatch and efslum. It will go ahead and run it for me in the batch. Once everything is done, you again, as I said, you can post process locally on this machine, or you can take it to your Windows machine by transferring the files. Same way what we did from the Windows, you can see them and copy them in the Windows machine. Before I go, I want to remind you that please, once your job is done, everything is done, please stop all these resources. All you need to do is by click stop, 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 and stop. This concludes the demo. Thank you very much.